Today we are presented with the problem: find the values of n where n to the 2m plus 1 is a square number. Well, the way we'd write this in terms of algebra is n times 2 to the m plus 1 equals a number squared. So that number is k. It's k squared. From here I just rearrange and bring the 1 over to the right hand side. Here we got the difference of two squares, so we factorize k plus 1, k minus 1. Now, well, when we're presented with a very vague question like this, what I do is I test values. So if I test for when n equals 1, n to the 2n plus 1 here equals 3, which is not a square number. When n equals 2, we've got 2 times 2 squared plus 1, which is 9, which indeed is a square number. 3, we've got 3 times 2 cubed plus 1, which is 25, and that again is a square number. So as of now we've got n equals 2 and 3 are values which satisfy our expression. N equals 4, we've got 4 times 2 to the 4, which is 4 times 16, 64 plus 1, 65. For our last value of n, let's choose 5. So 5 times 2 to the 5, which is 160 plus 1, 161. Again, not a square number. So now that we've got a better idea of what values of n work and give us a square number, we can go ahead and evaluate our equation here. Well, first thing to consider is when k equals odd, what information are we presented with? So when k equals odd, we've got n to the 2n. Well, k plus 1 means an odd plus 1, which is an even. We can write even. And k minus 1, so odd minus 1 is also an even. So what we're saying is n to the 2n equals an even times an even. So we can say 2 to the n is always even, bar from when n equals 0. 2 to the n is always even. So when n equals 1, we got 2, n equals 2, we got 4, 8, 16, and etc. And we're saying that n equals even, and this, yeah, it does work. So we can tick when k equals odd. What about even? A equals even. Well, n to the 2n equals, now we've got odd times odd. Well, we know that an odd times odd is always an odd. We can take the example 3 times 7 is 21, 5 times 9 is 45, always getting odds. And if you look at our left hand side, we've got n times 2 to the n, so we've got n, which you don't know is even or odd, times an even. Now any number times an even is even, so this expression cannot work. Fine, now that we know k is always odd, we can rewrite k as, let's say, 2m minus 1. And if you sub this back into the equation we formed, we've got n to the 2n equals 2m plus 1 minus 1. 2 times 2m minus 1 minus 1. N times 2 to n equals 2. Sorry, I forgot to write minus 1 in there. We've got 2m times 2m minus 2 which equals 2m minus 1, which equals 4m times m minus 1. Now we can further simplify our equation by dividing by 4. So we've got n times 2 to the n all over 4 equals m times m minus 1. And 4 can be written as 2 squared, so 2 to the n minus 2 squared is n equals 2 to the n minus 2. So n times 2 to the n minus 2 equals m times m minus 1. Again, we should consider our cases when m is odd or when m is even. Well, we know they're never both going to be odd and odd or even because we've got two consecutive numbers. We've got an integer minus 1. So if m is odd, we get m as minus 1 as even. So write this on the side here. M equals even. M minus 1 equals odd. So right. Now, from here, we can use some divisibility notation to write n times 2n to the minus n times 2 to the minus n minus 2 is divisible by m times m minus 1. For even here and an odd here, even, n we don't know is even or odd. We can say for certain though that 2 to the n minus 2 can divide m because they are both even. And if you take the converse, when m times m minus 1 divides n times 2 to the n minus 2, well, we can say m minus 1 divides n. And our two formed expressions here we can write as inequalities. So if a number divides another number, so 5 divides 10 and gives us 2, we can say that a divisor is always, well, 5 in this case is always smaller than 10, so 2 to the n minus 2 is always less than m. And it can also be equal to, since let's say 5 divided by 5 equals 1, so that also works. Here we'd have m minus 1 is less than n. So let's merge our inequality. So where we've got m, let's sub in 2 to the n minus 2. So 2 to the n minus 2 minus 1 is less than or equal to n. And if you go down, well, let's just put a red box around this because this is quite important. Now let's take a case when m is odd, where m minus 1 is even. So we know n 2 to the n minus 2 is m times m minus 1. So we know that 2 to the n minus 2 always even. So we can say 2 to the n minus 2 divides m minus 1. And taking the converse, we can say m, we can say that m divides n. And if you write our inequalities out, 2 to the n minus 2 is less than m minus 1, and m is less or equal to n. Again, if you merge our inequalities, we get 2 to the n minus 2 is less than n minus 1. Again, let's draw a red box around it. Now, let's test our inequalities to see which values of n actually work. So if you take our first one, 2 to the n minus 2 minus 1 is less than n. Well, if we use n as 1, we'll have a fractional part, which obviously isn't useful, because then we'd have a fraction which does not give us a square. So if we sub in n as, let's say, 2, we get 2 to the 2, we get 0 is less than or equal to 2, which works, correct? N equals 3, we get 2 to the 3 minus 2, so that's 2 minus 1, which is 1, sorry, is less than or equal to 3, which also works. N equals 4, we get 2 squared minus 1 equals 3, which is less than 4, which also works. N equals 5, we get 2 to the 5 minus 2, which gives us 8 minus 1, 7. 7 is less than or equal to 5, which is incorrect. And as we get larger, so we take a really large value of n, let's take 500. We know 2 to the 498 minus 1 is obviously larger than n, 500. So this inequality does not hold true for such large numbers. So we can say here n is less than or equal to 4 for this inequality. Now if you move over to our second inequality, 2 to the n minus 2 is less than or equal to n minus 1. We don't check n equals 1. N equals 2, we get 2 to 0 equals, so when n equals 2, we get 1 divided by 1. 1 is less than or equal to 1. N equals 3, we get 2 to the 1, 2 is less than or equal to 2. That works. When n equals 4, we get 2 to the 4 minus 2, which is 4, less than or equal to 3, which doesn't work. So our inequality only holds true for when n is less than or equal to 3. Now if you merge our two inequalities, we get n is less than or equal to 3. So we know our values of n can either be 1, 2, or 3. Now if we go back to our first step where we checked small cases, n this equation here is only satisfied for when n is 2 or 3, and this checks out with our inequality, so we can say the n times 2 to the n plus 1 is a square number of values 2 and 3. And that's how we'd go about a question like this, by considering different cases and whether they're odd and even, and seeing and setting up some equalities using some divisibility stuff. That's all for today. Thank you. Bye-bye.